ICMP version 6 is an integral part of IP version 6. ICMP, Internet Control Message Protocol version 6, like in the case of version 4, performs error reporting and diagnostic functions. ICMP version 6 messages then exchange or send error messages and information messages. The information messages are related with the diagnostic functions supported by ICMP version 6. ICMP version 6 messages are transported by IP version 6 packets, and in fact, IP version 6 next header value for ICMP version 6 is set to value 58. ICMP version 6 header is composed by those three main fields: the type, the 8-bit length type, the 8-bit length code, and the 16-bit checksum in order to validate the integrity of the ICMP message. When the high order bit of the type is 0, that is the range from 0 to 127 type, in that case, the message indicates an error message. Instead of that, when the high order bit is set to 1, that is a type range from 128 to 255, those messages indicate an information message, that is for typically diagnostic or configuration. The code depends on the message type and provides additional information. Checksum provides a minimal level of integrity verification. Then in this picture, we could see the different types of ICMP version 6 error messages. Typically, type 1 indicate the destination unreachable with different codes. Most of those are similar to the codes and the type and code used in ICMP version 4. That is, for instance, address unreachable, port unreachable, and other similar ICMP messages. For instance, the type 3, time exceeded, is very similar to that used in IP version 4. That is a hop limit, that is time to leave, like in the previous IP version 4, hop limit exceeded in transit, or fragment reassembly time exceeded. And there is, for instance, a new type of error message called the packet too big, and this message is used in order by typically the host that need to discover the MTU that they need to use to fragment in the source the IP datagram, in order to avoid the fragmentation, the need of fragmentation in the transit of the datagram. Remember, when a host sends a packet to a destination with some size, if some router detects that the packet is too big to be sent across a link, that router will drop the datagram and send to the source host ICMP version 6 message called packet to big, indicating the packet to big, the MTU of the next link. In that way, the host discover which is the appropriate MTU that need to be used in order to fragment in the source the datagram, and in that way avoid the fragmentation in any intermediate router. And this is typically the ICMP information messages like in the previous version 4, that is echo request or echo reply that are often used, for instance, in commands like ping or source or trace route. But there are a lot of other informational messages, for instance, in order to implement other functions, other diagnostic and other configuration functions. For instance, ICMP version 6 has a framework for extensions to implement several new features. For instance, Neighbor Discovery Protocol, NDP, is a node discovery protocol based on ICMP version 6, which replaces and enhances functions of ARP. In that way, a host could get the MAC address associated with a particular IP version 6 address. And there are other new features like, for instance, multicast listener discovery, MLD, that is used by IP version 6 router in order to discovering multicast listeners on a directly attached link, much like IGMP, that is Internet Group Management Protocol, used in IP version 4. And for instance, multicast router discovery that allows the discovery of multicast routers. Other ICMP version 6 information messages like router solicitation, router advertisement, neighbor solicitation, neighbor advertising, or redirect the message. All of those messages defined to be used by the neighbor discovery protocol. Then, for instance, in this case, we will see how the NDP, the Neighbor Discovery Protocol, use those ICMP version 6 messages in order to perform an address resolution. When we talk about address resolution, is, for instance, in this case, this host need to send, for instance, a datagram to this other host. But then workstation A needs to send data to C. It knows the IP address, it knows this address, but it doesn't know how to send the packet because it doesn't know its MAC address. That is, the host A needs to know this MAC address associated with this IP address. To discover this information, the host A sends a neighbor solicitation, and C, the node C, respond with the neighbor advertisement. Those are typically examples. Then, for instance, this is the typical neighbor solicitations that is sent by the host A. In this we could see that this, in fact, is the IP header. This IP header, there is a next header called 58, that is the payload of the IP version 4 datagram is, in fact, an ICMP message. And this ICMP message is type 135. Remember, 135 is the neighbor solicitation of NDP. The neighbor solicitation of an NDP. Then in this ICMP information message, in fact, previously this is the destination address of the IP version 6 datagram, and this destination address is what is called the solicited node address for the target workstation. Is a special type of multicast. Every workstation must respond to its own solicited node address, but other workstations ignore it. Then remember, for instance, this address is formed using this particular prefix that is a multicast one, and the less significant bits, in fact, are part of the MAC address of the destination host to which the neighbor solicitation is sent. Then the importance of the use of this particular multicast address is that only the destination host will listen and respond to the neighbor solicitation. This is a main difference, for instance, with the ARP protocol used in IP version 4. Then another particular information that is sent in the neighbor solicitation is the target address. The target address is the known IP address of the target workstation. That is the known IP address of the target workstation. And there is another information in the neighbor solicitation that is called the source link layer address. That is the MAC address of the host A. That is the source link layer address is useful to the target workstation and saves it from having to initiate a neighbor discovery process of its own when it sends a packet back to the source workstation. Then this information is very useful in order to avoid that the host C, in this case, need to send a neighbor solicitation of host A. Finally, the neighbor advertisement is addressed directly back. Then, when the host C receives the neighbor solicitation, the host C will send a neighbor advertisement to A. Then the neighbor advertisement is addressed directly back to the workstation A, directly back. This is the destination address of the IP version 6, that is this address. The ICMP message option contains the target IP address together with the target's link layer, that is the MAC address of C. That is, in the neighbor advertisement, the host C send to the host A his IP address and his MAC address. And in that way, the host A could get the MAC associated with the IP of the destination host. And then there are other needs in order to configure the host. Then, for instance, the NDP, the Neighbor Discovery Protocol, specify the way in, that host could get router and prefix information. A node needs to communicate not just with other nodes on the same link, but with nodes on other network segments that might be anywhere in the world. In this case, there are two important pieces of information that the node needs to have. The address of a router that the node can use to reach the rest of the world, and the prefix or prefixes that define the range of IP addresses on the same link as the node that can be reached without going through a router. That is the prefix in order to know which are the local destinations. Routers use ICMP to convey this information to hosts with router advertisements. And then this is typically a router advertisement. A router constantly sends unsolicited router advertisement at a frequency defined in the router configuration. The destination address, this one, is the special multicast address that defines all systems on the local link. The type in this case, 134, is the ICMP router advertisement. Router life, typically this one, this field, specify how long the node should consider this router to be available. If this time period is exceeded and the node doesn't receive another router advertisement message, the node should consider this router to be unavailable. The other parameter is a reachable time, this one. This setting sets a parameter for all nodes on the local link. It is the time in milliseconds that the node should assume that the neighbor is still reachable after receiving a response to a neighbor solicitation. And there is another parameter, retransmission timer. Retransmission timer, this field sets the time in milliseconds that nodes should allow between retransmitting neighbor solicitation messages if no initial response is received. Then typically this is the information, and in fact a router advertisement generally has one or more attached options. Those are the possible options. The three possible options in a router advertisement message are the option 1, that is called source link address, allows a receiving node to respond directly to the router without having to do a neighbor solicitation. Then the source link address. The source link address of the router. Option 5, MTU, specify the maximum transmission unit size for the link. For some media, such as Ethernet, this value is fixed, so this option is not necessary. And the option 3, this one, is the prefix option. The prefix defines that option defines the address prefix for the link. Nodes use this information to determine when they do and don't need to use a router. Prefix options used for this purpose have the L bit from a link set on. Prefix options are also used as part of address configuration, in which case the A bit is set on, the A that comes from address. And in fact, there is another ICMP message that could be used. A node might want to obtain information about the nearest router without having to wait for the next scheduled advertisement, for example, a new workstation that has just attached to the network. In this case, the node can send a router solicitation message. The destination address is this one, is a special, this destination address is a special multicast address that defines all routers on the local link. The option one of the message is a source link address, allows the receiving router to respond directly to the node without having to do a neighbor solicitation. It's the same that is used in other NDP messages. Each router that receives the solicitation message responds with the router advertisement sent directly to the node, not to the, remember, to the this special multicast address. And then is sent directly to the node that sent the solicitation, not to all the system local multicast address that is FF02 and with the less significant bit, the less significant bits in 1. Well, then there are different ways in order to configure the host. Then there is that set of mechanisms are typically defined in the stateless auto-configuration definition. IP version 6 then directly supports this SLAAC, stateless address auto-configuration, using NDP, which is based on ICMP version 6. NDP is the replacement of IRP. We already see that. Via the multicast address, this one, the prefix of the network, the lifetime and the MTU are requested from the router. We already see this in this case of the router and prefix discovery used with the router advertisement message. Then once the prefix is obtained of the network, of the local network, of the link local network, the interface ID, that is the less significant 64 significant bits, the interface ID is assigned by the host itself, for instance, using this that is called the extended, typically the extended, we have here this, the extended unique ID. We will see that we could transform the MAC address, the 48-bit MAC address, in a 64-bit extended unique ID that we use here in order to identify the interface. Then the interface ID is the 64 less significant bits of the IP address, and the most significant, the most 64 significant bits of the IP address are defined by the prefix of the network. And in order to, when the host use this mechanism to establish the interface ID, the double assignment of an address is prevented using this mechanism called duplicate address detection, which is realized with NDP, Neighbor Discovery Protocol 2. Using a mechanism very similar to the address resolution mechanism of NDP. There is another way to assign an interface ID to the host that is called privacy extensions and defined in the RFC 4941 that allow a host to select a random interface ID and change that ID over time. Finally, the DHCP version 6 defined in this RFC is only required for what is called the stateful address configuration. Then, to perform address configuration on IP version 6, there are a couple of familiar methods and a few additional methods, including static addressing. This is similar to the method applied in IP version 4. Dynamic addressing using DHCP version 6, that is what is called the stateful configuration. This is similar to the mechanism used in the dynamic addressing using DHCP version 4 in the case of IP version 4. And for instance, static addressing using DHCP version 6, very similar to the use of static addressing with DHCP version 4 in the case of IP version 4. Finally, there are a new mechanism called SLAAC, and we could use stateless address auto configuration alone or in combination with DHCP version 6 stateless, that is static addressing with DHCP version 6, a combination of SLAAC and DHCP version 6. Then remember, SLAAC state that comes from stateless address auto configuration provides the ability to address a host based on a network prefix that is advertised from a local network router via a router advertisement. The router advertisement messages are sent by default by most IP version 6 routers. These messages are sent out periodically by the router and include information including the prefixes, the prefix lifetime, the default router, and other information. SLAAC is implemented on the IP version 6 client by listening for the local router advertisements and then taking the prefix that is advertised to form a unique address that can be used on the network. For this to work, the prefix that is advertised must advertise a prefix length of 64 bits. And in this case, SLAAC will then dynamically form a host ID that is 64 bits long and will be suffixed to the end of the advertised prefix to form an IP version 6 address. Originally, the host ID was formed using the EUI-64 rules, that is the same that are used to form link local addresses, and many devices still use this method. Then this is the way that host could perform the conversion of the MAC 48 bits address to the extended unique ID 64-bit address. And then the address is typically the MAC address is this one, 48-bit long, and we split this MAC address and insert in the middle this information, that is those 16 bits, and we change typically this bit, this one, and we insert this information, and in that way, for instance, in this example, if we had this MAC address, that is 39A79407 CB0, we transform this MAC address, this 48-bit MAC address, in this extended unique ID of 64 bits, inserting this code FFFE and changing. Remember the bit, the manufacturer code bit to 1. That is the bit 7 from the most significant bits to the less significant bits order, in that order. Then we change this bit to 1, and that's why instead of 39 we use 30B. Remember that information is use an hexadecimal notation.